So good afternoon. Thank you for coming to SUSECON. Thank you for buying our products. Thank you for putting up with us. All of those things. So my name is Jay Kremke. I am the product manager for SUSE Linux Enterprise for ARM, among other things. And what we're going to talk about today is it's finally time for ARM in the data center and beyond. Catchy name. Don't know who came up with that. But as you might have seen in the previous discussion, Griff from Qualcomm and Michael were talking about some of their kind of transformation into bringing ARM into the data center. To give you a little bit of history before I go to my history slide, I started with SUSE about 3 years ago, and I was brought in as the first product manager for ARM. So I had this wonderful assembly of different parts and things that people had been working on, and an engineering team that was doing wonderful things, I think. And we were trying to figure out what were we going to do with ARM in the industry. And you know, ARM had been going through a transition for a long time to try to get into the server market. And there were various attempts at what was going to be kind of the defining value of ARM in the data center. And one of the things people talked about was, well, if I could do the same thing at lower power than on x86, that'll be great and people will love us. Well, that was okay. It was an okay message, but the reality was people really wanted lots of power as well, lots of compute power. And so, you know, the industry went through a lot of transitions, as you'll see, over the past couple of years. But we were able to get SUSE Linux Enterprise out for ARM, and we've done multiple iterations of it, as you'll see. And what we're seeing now is that ARM certainly does have a place in the data center, and we finally started to see the kind of hardware capable of performing in the data center. But what we accidentally discovered is that there was also a lot bigger, or a lot more interest in ARM in other locations, areas where x86 really wasn't a good fit. And so we're able actually to cover all of those with SUSE Linux for ARM, as you'll see in the few slides forward here. So I'm going to talk a little bit about the current state of the ARM server market, which has gone through a lot of transitions over the past 3 years. I'm going to talk specifically about some of the ARM solutions that are out there, so people who've actually deployed or are deploying ARM in a variety of kind of interesting ways. I'm going to spend some time talking about the challenge, I'll say challenge, of ARM processor diversity. And the reason why I'll bring this topic up is if you look at all the other processors that are out there today, if you look at, you know, for example, x86, you've got basically 2 vendors. You've got Power, 1 vendor, effectively, and for System Z, you know, the Z processor, 1 vendor. So all of those kind of legacy platforms really have kind of 1 or maybe 2 people kind of driving it. In ARM, it's the exact opposite. You have everybody in the world in it, hundreds of people that are trying to produce some sort of processors for various ARM workloads. Some of those are server class platforms, many are below that, but the diversity of ARM is both its blessing and its curse. It's a blessing because you can get just the right processor for the particular application. It's the curse because instead of having to deal with 1 or 2 or 3 different manufacturers, we have to deal with hundreds of them. So it makes for a lot of challenge. That is really kind of leading into the next discussion is our pricing model for ARM. So, you know, I'll talk more about this later, but we had to change how we priced ARM compared to the other platforms because of the diversity of the previous line. I'll take you through some examples and we'll talk a little bit about kind of what's coming next. Ooh, and then deja vu. All right, so let's talk about ARM industry events. And there's been a lot of stuff that's gone on here. Now, up at the top, you see the green boxes. Those are things where SUSE has shipped products. And our first introduction was with SLES 12 SP2 for ARM. Came out back in 2016, and we announced it actually at SUSECON. So it was right around, well, actually we announced it a little before, but it really became available at SUSECON in 2016 when we were in Prague. We had taken SLES 12 from the 3.8 kernel to the 4.4 kernel because we just needed a whole lot of things that were in 4.4 for ARM. We had a number of different processors we supported out of the box initially. The Cavium, then ThunderX2, the Applied Micro X Gene 2, and the AMD Opteron 1100. Haven't heard much about AMD in a long time, but That was the kind of guys that lined up there. And we were really going after a number of different workloads. The first one was high performance computing, the second was network processing, and the third was storage. And so we've seen various kind of traction among those different ones. Now, meanwhile, in the manufacturers, the system on a chip vendors or SoC vendors, they're going through a lot of different changes along the way. So, for example, there was a company called Cavium that developed this ThunderX2, and it was 48 cores. It was kind of an interesting box there. That was kind of one of the heftier boxes that were out there. Some companies got out of the business. In fact, more than one company got out of the business. So, for example, Broadcom was working on a processor they call the Vulkan processor. And I remember distinctly in Supercomputing 2016, the Broadcom guys were suddenly completely missing, okay, because they kind of terminated that project. Cavium picked that processor up, and it became what is now known as the ThunderX2 processor. Now, Cavium, as you can see down the line here, got purchased by Marvell. So, as I said, there's been a lot of consolidation going on in the industry. Had similar things with Applied Micro. Their processor ended up at Ampere. Qualcomm entered the market and kind of exited the market. So we've seen a lot of stuff going on over the time. So it hasn't been the most, I'd say, smooth ride. It's been kind of a rocky, choppy ride here. One of the kind of interesting things, though, as you'll see later on, is we started to see some of the unique values that ARM processors could bring to specific industries. And in particular, the ThunderX2 really started showing some differentiation over x86, and that's differentiation that exists today. And that really started to wow people. They said, wow, for certain workloads, these ARM processors can really do high-performance computing a lot better than they could with x86. And so you start to see some systems based on the ThunderX2 processor show up at Sandia Labs, which became the first ARM system in the top 500 last year. We have a project called Catalyst UK that is also based on the ThunderX2 and with HPE, and you'll see a number of those things. So kind of the idea here is I'm only showing some of the kind of major things, but there's been a lot of turmoil in that ARM market over the past 3 years. But we're starting to settle down. So SUSE Linux Enterprise Server for ARM, we initially kind of targeted this at early solution developers, so people who were developing on the platform for the first time. That was because, as you might have heard in Griff's presentation, a lot of the vendors for third-party software really weren't on ARM yet. And so that's going to take a while. We still have, we have a lot on there now. There's obviously always more to go. But, really the idea was how do we get this out here and get people starting to build solutions on it. So we did the initial release with SLES 12 Service Pack 2 in November of 2016. We did the next one in August of 2017. SLES 15, of course, came out last year, and at this point, SLES 12 SP4 is just turning the crank. There's not much science. As Griff said in his press presentation, it's just becoming boring, right? The first couple of releases are a little bit rocky, but after that, it just kind of moves along. So I wanted to kind of show you just the context of what we were trying to do with these releases. So initially, we were really all interested 100% in getting the SoC enabled. So getting the SoC actually to run, working with the vendors to get the device drivers and such kind of running there. That was really kind of our biggest driver at the beginning of it. But as we started driving things like SUSE Enterprise Storage, we started working on solutions. How do we build things that are kind of specifically tailored for ARM? I don't know what that door is. And what you'll see over time is as we kind of move forward, we're really kind of focusing, number one, obviously there's still more SoCs coming out. So I'll talk a little bit more about this in the future, but there are a lot of SoCs under development. So ARM, if you don't understand how ARM itself works, ARM licenses the IP to build chips to an SoC vendor, and the SoC vendor, depending upon their kind of license, they can either just take ARM's design and make it into chips directly, just take the design straight from ARM, or if they're an architectural licensee, they can add more stuff to it. Now they still have to maintain the still have to maintain the ARM architecture, so they have to maintain within that. But those architectural licensees get a lot of ability to tailor their actual chip to specific workloads. And so the guys like, for example, Cavium, now Marvell, Qualcomm, Ampere, all of those guys are architectural licensees that can have a lot more leeway to do some interesting things around it. So we got SUSE Enterprise Storage 5. We actually got that pretty early there at the beginning of 2017. Unfortunately, we didn't really have the vendors kind of driving it. So we hadn't had the capability there. Meanwhile, on the SUSE side, we were doing some things around high-performance computing. And one of those things we were doing is we introduced this concept called the HPC module, where we actually include software specifically for HPC environments as part of our HPC distribution. When we came out with that back in the beginning of 2017, we did support x86 and then about a month later ARM. So we did have those two platforms, and we continue to support those two platforms. Now it's just all at the same time because it's gotten boring again. We just turn the crank and come out with a new generation. Service Pack 3 gave us a lot of things. Number one is it gave us the SoCs for ThunderX2. So that was really kind of a groundbreaking processor in terms of capability, but it also allowed us to do a lot of the work in the background at SUSE, getting OpenQA working, kind of just standardizing ARM as just another platform within SUSE. So once again, this is a lot of work that goes on the background you guys don't see, but it just is part of us normalizing that platform. Now, along the way there, back here in 2017, when we came out with SLES for ARM, my manager, Matthias Eckermann, actually was he was at a sales meeting with another guy, and I'm sure alcohol was involved, but they said, wait, the Raspberry Pi Model 3 is a 64-bit ARM processor, and SUSE only does 64-bit ARM. So the idea came up, gee, could we get SUSE Linux Enterprise to run on a Raspberry Pi Model 3? Sure. Well, lo and behold, thanks to our engineering team's cleverness, we were able to do that. Now the Raspberry Pi, if you spend time looking at it in detail, is designed to be inexpensive. It's not designed to be a very good server platform, but it's also not designed to actually kind of be consumable as just another server platform. So there were a lot of things we had to work through there. But the bottom line is, we handed out these little boxes with SUSE Linux Enterprise Server, SLES 12, SP2 on the Raspberry Pi at SUSECON in Prague in 2016. And everybody had a good time with it. We caught one customer trying to shove several into his bag, because people were excited about it. It was an enterprise operating system on this little bitty $35 box. And so that was pretty cool. So we shipped it. We asked around, people were interested and said, are you interested in running this commercially? Nah. So when I shipped, right before I shipped SLES 12 SP3, I was at release candidate stage. So in other words, we were like a few weeks away from Golden Master. I get two companies that come up and say, okay, we're ready for the Raspberry Pi to be fully supported. And we go, wait, okay, we're not there. So we went through a lot of fun over the next few months, and we basically added SLES for ARM, we added Raspberry Pi support to it. And this was really focused on a couple of use cases that I'll talk about later, but it was not something we wanted to do, really. We're not in the little bitty server business, we're in the server operating system business. But we've changed. Along the same way, those same customers said, oh, by the way, if you give me your SUSE Linux Enterprise Server on the Raspberry Pi, of course I want SUSE Manager for that. Of course, right? So luckily that was easy, because it turns out the SUSE Manager team was proactively testing on ARM, and guess what they were using to test? Raspberry Pi, right? So that was an easy sell. So anyway, so we introduced that support. We'll talk more about that in a moment. Now, meanwhile, we had SLES 15 come out last year. We moved the kernel up to kernel 4.12, toolchain, everything kind of. And once again, this is starting just to be more turning the crank, ARM becoming just another platform. We're not 100% there yet, but it's getting pretty close. And by SP4, that wasn't even noticeable. That's just another SLES release. Didn't really pay anything. Now, meanwhile, we're always adding additional SoCs. More SoCs are coming out all the time, or revisions to existing ones. And one of the areas that we've started to focus on is what I call ODM and partner enablement. Because obviously just having a chip is nothing without a system that's built around it. And this is where one of our challenges is. A lot of the people that work in the smaller space, not the server space, but kind of lower down, are used to having kind of handcrafted, Debian releases that they put on their hardware, they throw it out the door, and that's the last they ever mess with it again. So getting them to support, EFI and things like that, Pixie Boot, all of those kind of nice things that we need in enterprise space is a bit more of a slog. So we're going to continue to work through that over time. And then we've also got some solution enablement. So I talked about SUSE Enterprise Storage. We've got a SUSE Enterprise Storage 6 coming soon that will add a bunch of SoCs to it as part of that. I'm inheriting that. But that's going to continue to build out. All right. Let's go forward here. Didn't I go there already? Sorry. I'm going backwards. Okay, so what do we have today? Well, obviously we have two products, really. We have SUSE Linux Enterprise Server for ARM, and we have SUSE Linux Enterprise HPC, because we split the HPC product off as a separate product in the SLES 15 timeframe. If you want to know more about that, come to my HPC session. But we do have two products, two operating system products around ARM right now. I mentioned that we have the HPC module that in general has the same content as x86. There's one or two packages that are x86 specific, so they're not there. We also have Package Hub. Most of you are probably familiar with Package Hub. We have over 500 packages. The last time I looked, it's probably more than that now. So we've been building out the amount of packages that are out there. Of course, OpenSUSE Leap, is our community-supported Linux. That obviously has ARM as well. We did add free developer subscriptions last year. So one of the things we noticed was, gee, what's the thing about ARM? You want to develop new things on it? Well, how do you get a developer subscription? It's included, or it's available just like x86. And then we have some other products that I'll talk about in a bit more detail later. So we actually do have a fairly robust set of things out there today for ARM, but we're continuing to expand things. So we'll talk a little more about that in the future. All right, let's talk about really big ARM systems. So this is Astra. This is based on HPE's Model 70, ThunderX2, 2,592 compute nodes. It's the biggest ARM HPC system in the world right now. They got delivery of the hardware kind of third quarter of last year, and they were able to actually get qualified for the top 500. So it is the only one on the top 500. I would talk about this a lot more if it was running SLES, but I won't. Okay, let's talk about the ThunderX2. So I mentioned that the ThunderX2, the ARM processor that is in use by the Apollo 70 and some others that I'll tell you about, does have some kind of unique advantages. And one of the areas that they have more paths to memory. So they have a pretty significant memory advantage, or memory transaction ability to move memory much faster than the Skylake, okay? And so this is important for particular workloads. So going back to HPC, if you have a workload that is doing something that requires a lot of in-memory work, so things like computational fluid dynamics, for modeling automotives or things like that, this is really good stuff, okay? This gives you an advantage over the Intel processors, the x86 processors that are out there. Now, if your workload is computational heavy, then probably this processor is not going to be the best one for you. But there are significant price advantages for the ThunderX2 compared to the high-end Skylake processors. So even if you don't get as much performance as a Skylake, it still might be worth your while to play there, right? So we have a lot of different workloads that we're playing around with right now. And the idea is that we want to get a better idea of what things are these ARM processors really good for, or the ThunderX2 in particular, what are they not. Now, one of our other partners, Cray, also got into the ARM arena quite early. And so they produced this thing called the XC50. They announced this at Supercomputing in 2017, or 2017, right? 2017. They have a little bit different layout than the HPE. They have 4 cores on a board. 4? Or is it 8? They have a lot of boards. They have a long board, a lot of things on it. And they put this out at an installation called Isambard. It's in the UK. They say it's a tier 2, so UK has different tier levels for HPC. Question?
Is that the University of Edinburgh?
Yeah, University of...
Bristol Bath next time. That's
Bristol, yeah, Bristol Bath next time. Hold on to that thought, though.
Catalysts.
And this is one of the kind of the interesting things that showed that difference. So you can see in some of these workloads, where the ARM processor, the green one here, is far above the Skylake or the Broadwell Intel processors. Those other areas, we're not so much, right? So it is workload dependent. It's not that you're going to run on ARM and it's going to do everything better. But the idea is that for some workloads, it's going to run substantially better. And for other workloads, you may be able to trade off the lack of performance for a specific workload on the case of lower cost. So there's a lot of kind of interesting ways you can play this game. Now this is the project you were probably thinking of, the Catalyst UK project. So this is a partnership between SUSE, HPE, and ARM. And the idea here is to kind of do something similar to what they did with the Isambard, where we actually said, let's put some scientists, we're going to put some installations out there, 64 Apollo 70 systems per site, 3 sites, Bristol, Leicester, and Edinburgh. And they're going to start to actually, number one, look at the software stack, see where there are areas where the software stack needs some adjustments. In most cases, things, just compile and run. But when you're dealing with high performance, you're really kind of focusing on individual performance. So they're going to find some areas where they need to make coding changes to really wring the last bit of performance out of it. They're also going to run into bugs and other things, right? So it's kind of a learning experience, but it's also exposing people in this industry, in the high-performance computing industry, particularly in academia. They're giving them the example to run on these systems. So they have workshops where people come in and learn to use them. Now, these systems were delivered right around the end of supercomputing last year, so say around the December time frame, and we've stood them up. They're now up and running. All the sites are up and running, and we're kind of in the early stages of seeing what we're going to get out of it. So we expect that we will have some benchmarks by the ISC conference in June. Everything won't be completed. It's a learning experience. This is really learning systems. So every one of those systems is running on the Apollo 70 that has 232-core Marvell ThunderX2 processors per system. And that's actually something I should point out here. You'll notice 32 cores. If you look at most of the x86 cores out there, or most of the x86 systems, you might see 12 cores per processor. You might see, a few more than that. But generally, you tend to have kind of lower core counts per processor. In the ARM environment, because they started with basically a fresh design, they can do lots more cores. Now, in some cases, the cores are not as performant as you would get from an x86 core, but you got lots more of them. So if you've got a workload that can be spread out over more cores and get value out of that, then you're going to see a pretty good performance boost out of running on ARM versus x86. Now, where are we with this? They're deployed. They're currently running SUSE Linux Enterprise SP3, SLES 12 SP3. HPE has a high-performance computing stack they call HPCM, so they're using that since it's an HPE partnership, and they provide the hardware. We have provided the Slurm Workload Manager. It's part of our HPC module. We provided that to the Catalyst customers. And it's still kind of the initial qualification and performance testing. So they're not really running big science yet. They're out there, they certainly are out there running. What we're looking to do in the kind of the future is at least one of the customers wants to upgrade to SLES 15. And we'll do that as soon as we get HPCM running on SLES 15, so we expect that to be fairly soon. One of the other things that we did include as part of this exercise, or part of this Catalyst UK project, is subscriptions for SUSE Enterprise Storage for ARM. So the ThunderX2 is not necessarily tailored to that particular type of workload, but we wanted to have people have the opportunity to experiment with it. Once again, this whole thing about Catalyst It's a learning experience on the software stack, and to some extent a testing experience for us. So you'll see more out of this. We have more work going on, and you'll see we'll have a birds of a feather session at ISC in June, and you'll see some other things before that. So this process, in place right now, 3 different installations. And when we say 3 different installations, talking to these guys, they run their HPC complexes completely differently. So it's not like, it's 3 cookie cutters. These guys are each doing unique things in their environment. All right, now we're back to our friend, the Raspberry Pi. Okay, so I mentioned we did provide commercial support for SLES 12 SP3. We did it in like December. So we did it a few months after SP3 officially GA. We currently support the Model 3, the Model 3 B+, and the Raspberry Pi compute module. So those are all supported by SLES 15. We're supporting all of those. In the future, we will have support for the compute module, B+, that's coming soon. And like I said, we didn't plan this. This was not part of our plan at all. We had customers that demanded it, and big customers. They said, look, I'm going to roll something out, and I want to have an enterprise operating system that I know is supported. Now, one of the challenges is getting the hardware support in here because I said there are some kind of idiosyncrasies in the Raspberry Pi, in firmware support in particular. So we have Bluetooth, Wi-Fi, HDMI, and things like that enabled. There are some things that are not currently enabled in the Raspberry Pi. 3D graphics being one that I really, really wish I had, but I don't have that yet. There's some other things around when you use particular I/O boards. So they do require a bit more kind of hand nudging to kind of take advantage of different I/O. But for general use, you can download SLES 15 for the Raspberry Pi. We provide it as a micro SD card image, so you can just download it, flash it to the card, stick it in there, boot it up, and install it. We do have some more enhancements. I'll talk about those later, what we're planning to do in the future with that. Now, why did we do the Raspberry Pi? Well, we had a couple of customers that came to us and they said, we have an industrial manufacturing environment and we have hardware in that environment, machines that drive our manufacturing environment that have lives of 30 to 40 years. Things like industrial drills. And, okay, so you think 30 to 40 years, that sounds okay. Well, think about it. Some of this equipment was produced in the 1980s, okay? And it's going to be in use for maybe another 10 to 20 years. So there's no instrumentation on it, You remember the height of the 1980s was the PC, I think, So there's nothing on these systems. And they wanted to be able to monitor what was going on. One of the customers also wanted to have a way for the manufacturing line operators to signal back when there's a problem, because not everything is a machine problem, maybe you ran out of parts. They wanted a simplified way to gather that information to improve their manufacturing line. There's some other ones that we've been contacted for. There was one company that wanted to do distributed networking monitoring, putting out there looking for DDoS and other network problems. We've had a couple around digital signage and restaurant kiosks. I don't have any of those that I know of itself. But when we ask, why are you using this? The Raspberry Pi is a completely, kind of underpowered little server. It's cheap, 35 bucks, right? What do you got to lose for 35 bucks? They're widely available. They're good enough for the work that they need, right? And so we have, we continue to have customers that come to us and say, we'd really like to use this. Now, I got one that right now that is currently referenceable. We've done a solution case study on. We'll talk about Kenora Bremsa in a moment. We've got some automotive manufacturers that are doing similar type workloads. Basically, the idea is they want to deploy Raspberry Pis inside their firewall, inside their corporate networks, and they don't want to run Raspbian or any other kind of open source operating system. They wanted SLES and they wanted SUSE Manager to put patches on that. So one up we're working on is doing 8,000, and these guys are kind of interesting. They not only want to monitor for what goes on, but their goal is actually to do proactive monitoring, so that they're actually going to be able to avoid outages in the future. I've got another really interesting one for environmental monitoring. I'll talk more about this in a moment, but this one's kind of interesting because it is not in a factory. It's deployed out in the world. In fact, you'll see an example of how they intend to deploy these things. but battery operated, solar powered, talking to a central station. But let's talk about Knorr-Bremse first. So if you're an American, you've probably never heard of Knorr-Bremse. If you fancy yourself, if you played around with automotive stuff, you probably heard of Bendix, okay? Knorr-Bremse started out manufacturing things like brake linings for trains, and they make a number of fixtures for trains. Knorr-Bremse actually owns Bendix now, so they actually are kind of a worldwide provider of commercial transport and various transport things. So they have a lot of what I would call heavy manufacturing, right? Once again, very long life, and so they wanted to have a solution out there that was monitoring what was going on and reporting back to a central station. So they are running SUSE Linux for ARM on the Raspberry Pi Model 3 and using the SUSE Manager to distribute fixes to them. So this is a very common model that we see in industrial kind of manufacturers. And you know, what I like about this is once you do one of these things, then people go, oh, this is possible, this is easy, I can do this. So we have another customer though, that I can't tell you the name of, that is doing environmental monitoring. They wanted to do a similar, they wanted to monitor lots, water levels in lots and lots of locations, I think around 4,000 locations. And so their idea was they wanted to come up with a Raspberry Pi in a particular ruggedized case with some kind of interesting I/O, and that I/O is being delivered on this thing called the MyPi Industrial Integrator, or MyPi Industrial IoT Integrator, which we have over at the ARM booth. So if you'd like to come by and look at one, and you'll notice it's got a Raspberry Pi 3 compute module plugged in here. So that's actually providing the brains for it. But then they have I/O modules that sit on top of it that can do a number of different I/O sensing things, or run wireless protocols like low WAN, for example, Wi-Fi, cellular, you name it. And the basic idea is what this thing's going to look, it's going to be sitting out on a pole in the water somewhere, solar power. So that one is currently in early deployment and acceptance testing. So we don't have, don't have an official thing there. This one's going to be kind of exciting. You think about 4,000 of these things scattered out around the country, reporting information out that will actually get integrated by a third-party analytics solution that's going to look at that data and do all the analysis and kind of getting into a good factor that can be used for, science and alerting and things like that. So this one's really kind of an interesting play on that. All right, let's talk about where we are today with SLES 15. So we have a number of different SoCs that we support. So system on a chip. So these are the chip level integration. And I've talked about some of these, the Broadcom for the Raspberry Pis, Marvell Octeon ThunderX and ThunderX2, ThunderX2 being kind of the HPC one. Continuum also has an Octeon TX processor. They also have an Armada, which actually we have one of those running. If you go to the Embedded booth, it's against the far wall. They're showing a SUSE Enterprise Storage running on the Marvell Armada 7040 processor. We've got some other guys out there. NXP, we're running an NXP in our ARM booth today, so you can go see that as well. NXP produces a lot of different ARM processors for automotive and other specialized uses. So they will, some of them are 2-core, some of them are 4-core, some of them have more cores than that. This is where the diversity of the ARM platform is really a value to them, because they can make these chips to fit a specific function at a specific price point, which is generally pretty inexpensive compared to x86, because, as any of you know, x86 you can put in your old 386 DOS program and more than likely it'll run. Well, it runs because there's area on that chip, on that x86 chip, devoted to running that old stuff. And there's lots of old stuff, right? That's not on the ARM chip. That's why we can get more stuff on ARM at a lower price point. We have the Huawei Compang 920. So Huawei has actually been doing a lot as far as creating server type level platforms. So that one, the Compang 920, is kind of interesting. It is once again a server class platform, but we have the range here, anything from the Rockchip 3399, which is a little bitty 4-banger, kind of a processor, all the way up to some of these 48 cores and above processors. So One of the key things though that I noticed, and I put on here, please check with your vendor, because the vendor's choice on how they put together their firmware really influences whether or not we'll work on them. And even for platforms where we have extensive experience on, like for example, the Octeon TX, we're working with a particular ODM. We've been working with them for months now to get the thing to work. It's because the firmware that the system vendor chose was really, really old and doesn't really kind of support the booting environment. So this is still evolving. It's getting better. It's getting a lot better over time. But just because you see the chip, enabled by SUSE, don't expect that you can go out there automatically and, try to boot SUSE on it. Might work. Might work better if you had, our ARM engineers doing it. But. Okay, we do have other products. So I've already mentioned SUSE Enterprise Storage. So SUSE Enterprise Storage 5 is out there. That is based on SLES 12 SP3. So the next release will be based on SLES 15. So we will pick up a number of processors with that release. So I'm really looking forward to SUSE Enterprise Storage 6, because there's a lot of processors that I think are going to be particularly interesting for that particular kind of a workload. We do have the SUSE Manager available. We have the lifecycle management component, so not the server, but the client side of it, the management side of it. We didn't see a need to put the server there yet. We'll get to that when we have a requirement. We've been doing SUSE OpenStack Cloud for a number of years. In fact, we demoed it in 2016. We just haven't seen the workload kind of materialize yet for us to make that available. But if it does, we can move forward with that. So we do have, the bottom line is we do have a number of products that are available now for the ARM platform. I mentioned Package Hub already. The ones that I highlighted in here are primarily stuff that are HPC focused. So you see a number of things that are cluster shell. For example, the Singularity runtime. So if you're familiar with container technology, there's a company called Scilabs that produces a container technology and runtime called Singularity. They have been supporting ARM from the very beginning as well. So Singularity is kind of a competitor to Docker or OCI style containers. And they have some unique differences that are really, really good for an HPC environment, once again supported on ARM. All right, now let's get into diversity. So here's my challenge. I'm the product manager and I have to price things. So how do you price SUSE today? Well, for most cases you price it by the number of sockets. 2 sockets, $7.99, okay? You want unlimited virtual, 2 sockets, $14.99. Well, this doesn't work very well in this kind of environment, because if you look at it, I've got cores, maximum number of cores too. I've actually got some 2-core systems, like the Octeon 2X can actually go down to 1 core. I don't know if anybody's going to make that. All the way up to 48 cores for the original ThunderX. By the way, this number 48 cores on a socket is not a high point. We'll go beyond that. There are people that will design it. There was one company, Tile, that was going to come out with a 100-core processor before they kind of flamed out and went away. But their technology is back as the Mellanox Bluefield processor that's out there at 16 cores. So I've got a really, really wide range. Obviously, if I try to charge $799 for a Raspberry Pi, I'm not going to get a real big adoption, right? Flip side is, if I sell, SLES for ARM for $50 on a high-end server, I'm also not going to make a lot of money because I'll be looking for a new job. So this was the challenge. How do we deal with this? Well, one way you could do it is say, okay, let's just go to a straight core-based approach. There are vendors like IBM and others that have used a straight core-based approach. The problem with that is then you start having to account for the difference in processor strength between cores. So if you've ever dealt with IBM processor value units or Intel core factors, you understand that's not a transparent and easy thing to deal with. So we kind of took a middle road with this and we said, okay, we're going to draw a line. We're going to say anything below that is core-based and everything above that is socket-based. And that's what we did. So when we released the ARM pricing last December, anything less than 16 cores, and 16 is quite arbitrary, but that's where we drew the line, so it's 15 cores, from 1 to 15 cores, we're going to charge you $50 for every 4 cores, right? So Raspberry Pi in this model, as you'll see later on, is 50 bucks. Unlimited VMs, which is kind of strange on a Raspberry Pi, but okay, $100. If it's 16 or more cores, then we just use the regular SLES pricing model. 1 to 2 sockets, $799, or $15.98 for unlimited VMs. One of the other things we did at the same time, and if you're a customer, you may not be aware of this, but we have multiple price sheets. So we have a price sheet that we call the corporate, or the MLA VLA price sheet, that everybody in the world can see. We have ISV prices that are only available to the ISV partners. Then we have appliance prices, which are kind of a starting point for somebody that wants to build an embedded application. We had, one of the things that we did as part of this is we put ARM with the same pricing models on all of those price sheets. So this actually opened up for people to actually start buying licenses for the Raspberry Pi without having to do any kind of special bids or anything like that. We also used the same model for the SUSE Manager. So we took the same concept. It's less than 16 cores. We're going to charge you per core group, or per groups of 4 cores. If it's more than 16, then it just becomes a regular SLES pricing for SUSE Manager. So we've kind of got a model here, and I won't tell you this is the model that'll stay forever. But you know, it was a first approximation to get us to a place where we can start to price down into that low space. And remember, that was not our business goal at all. What did I say we were going to do? We're going to do high performance computing, networking, and storage. Well, guess what? Raspberry Pi kind of forced our hand, which is a good thing, to be honest. Okay, so let's talk about the Raspberry Pi just quickly. So a pricing example. So it's 4 cores, number of cores divided by 1 is 1. So you need 1 subscription, 50 bucks, right? And you might say to yourself, but Jay, the Raspberry Pi only costs $35. Yep. Next step. Sorry, no. The reality is the value of the SUSE subscription is, you know, to some extent independent of the hardware it runs on. The value is knowing that you're going to get patches, you're going to get fixes, you're not going to have exposures in your environment. So, you know, list price 50 bucks, you can negotiate from there. If we look at the Marvell Octeon TX, now the Octeon TX has a number of different core options. In this example I chose was a 14-core Octeon TX. And so we divided that by 4, and we come up with an odd number that we round up to the next nearest one. So in this case, you're going to need 4 subscriptions, which means that that Octeon TX in the US list price will be 200 bucks. Now, SUSE Manager Lifecycle, I said we did the same approach here. So Raspberry Pi, still 4 cores, divided by 1, still 1 4-core license. So in this case, I think it's 8 bucks. Yeah, it's something like $8. So it's pretty inexpensive, right? Like I said, it's not the best model in the world, but it's one that kind of got us to where we needed to be, was to be able to compete in that low-end space. The challenge will be as we grow more processors in that middle space, you know, the 16 to 40 cores, that we'll have to adjust it again. But we have a starting point. Okay, what are we doing? What's next for SLES for ARM? So I mentioned that we do have a lot more SoCs coming. So there's some server class SoCs that will be coming out with SLES 12 SP1. Can't comment on the providers, but you will see server class chips come out there. You will certainly see follow-ons to the existing processors that are out there today. So all the guys that produce SoCs, they're always, you know, especially on the high end, are looking to rev them, provide more capacity, more capability. So at the hardware side, you're going to continue to see more and more chips become available, better chips become available. One of the things that we're really promoting with ARM guys, and others, for our SoCs is supporting the EDDR. So supporting kind of the enterprise standards so that we can take these chips these SoC vendors produce, the systems built on them, and just boot them and run them just like anything else. As Griff said in the early thing, just make it boring, just make it work, okay? So that's work that's going on as well. We are going to be building out our SUSE support for things. So right now, I do not have support for containers. So I do not have a container module for ARM today. That will be changing in the future as well. And then along with that, things for support for scheduler or for workload managers like Kubernetes will also follow. So we have to kind of build out where we go. But we're not going places that we're not just, you know, like the old movie, we're not just build it and it will come. You know, we're building forward to get ready for things. So in some cases we do make investments, but to move things to kind of a regular supported product like the cloud product, OpenStack cloud product, we got to see some demand. We got to see people that are out there using it. But you'll see more come out in that particular area. The bottom line is we're kind of at the early stages of this. So, you know, if you want to think about kind of PCs, we're probably about 1995 or 1992. You know, PCs are a lot out there. There's still a lot of variation. Some of them are just flat weird and won't survive, but there's lots of them. And what we've seen from the Raspberry Pi example is there are a lot of use cases that can be attacked with an ARM-based processor that an x86 processor is simply too pricey for. We were having a discussion the other day and somebody said, well, what should be the target price for something? And somebody mentioned $500 and I laughed at them. I said, no, people want cheap. If you can get it out there cheap, you can start to build into applications. Now, the high-performance computing guys are always going to be at the upper end of the scale, but even then they're quite cost competitive with their x86 rivals. So you will continue to see this build out. You'll see the incorporation of things like GPUs, for example. So there are vendors today that produce boards, that produce systems that have integrated GPUs for doing machine learning and AI. So that's an area of enablement that both we and those partners need to work with. There are other customers or other vendors like Xilinx, for example, that produce ARM systems or ARM chips that have kind of integrated FPGAs along with it, same type of use cases. So, you know, we see the capabilities of the hardware going to continue to evolve, continue to get stronger, and at the same time we're going to see more robust designs coming from the ODMs. But like I said, storage being is one of the ones I'm really interested in. So if you get a chance when you're in the solution showcase or whatever we call it, technology showcase, go check out the embedded guys at the far end of the build. At the far end, they'll show you an example that they have there of running an ARM-based SUSE enterprise storage environment. So that having been said, it's time to stump the chub. What questions might you have?
What about the new NVIDIA Jetson? Do you know?
That's a really nice little thing, isn't it? You're talking about the Nano.
Talking about the $99 one that is just.
Yes.
Yeah, I've got one on order, so. And there's some people that already, if they were at the show, they got them. So yeah, I'm quite interested in that particular processor. One of the things, and we've complained to the ARM guys, making fun of it, is that one of the things that people really would like to have is a development platform for ARM. And you know, there are a lot of boards out there, but their OS support has been kind of handcrafted. So we'd like to get to much more standardized things. You know, I don't know where the Nano will fit into that, but that would be an interesting chip for us. We have a number of customers that have expressed interest around things like digital signage, and you can do flat images. Right now, the Raspberry Pi can do that, but it doesn't have video decoding acceleration, and we really need that to do those kind of workloads. So some of that's work that we can do, some of it's work that we're going to need to work with the vendors on. The Raspberry Pi in and of itself is a challenge just because they have so many peripherals. So for example, one of the requirements that we have is to support the touch screen. So we're actually working on that now. We have a customer that wants to have the touch screen display work on the Raspberry Pi. But you know, those guys at Raspberry Pi Foundation, they crank out a lot of hardware, and you know, the various stages of whether or not, you know, when we can kind of prioritize it and try to work on it. Some cases, stuff isn't upstreamed, or the firmware doesn't report true capabilities or things like that. But it's an evolving state. And the Raspberry Pi for us, we really love it, but it's a four-banger kind of unenthusiastic processor. So we need more horsepower for other workloads. You know, in particular, if you look at some of the things around 5G, that is a space that we think has really got a lot of opportunities for us. We don't quite have all the pieces together yet, but that's an area that we're building out.
So I have a question. I've been beta testing various ARM boards for years, and a lot of them now are showing up as big little configurations, and in the hacked together OSs that I've been testing, there's really not much knowledge of what's big and what's little. And it doesn't seem to, even if you do C groups or something like that to try to define it, do you guys do anything in SUSE to understand if you're on a heterogeneous core system?
We have not done a lot of work in big little, just simply because we haven't had the workloads or the business requirements to support it. You know, that if we get those requirements, we'll invest more in that. But yeah, that's an area we just kind of steered away from.
So none of the hardware you showed up there is any big little?
None of the hardware we are doing today is big little. Everything that we're doing is 64-bit on. Yeah. You know, we've had people that have asked us about 32-bit, but if you look at it from the point of view of complexity, 32-bit is effectively another whole platform for us, and that's pretty expensive, right? So to support a $4 chip, you got to have a whole OS chain behind it. It's not.
I was running several benchmarks on a hexacore, and 4 of them are big and 2 of them are little, and watching where they got distributed, and it was all over the place. And very suspicious of the benchmark number that came back.
Okay.
You know, because who knows where it ran, really.
Yeah. Like I said, we got into the space looking at ARM as a server platform, so the Raspberry Pi was never the end of the market. So we'll see. Other questions? Yeah.
Back to your topic about the FPGA, but today for the mobile company chips like Apple, Samsung, or Kimi, they all come with AI chip or NPU, narrow, and also some other like partners that provide this kind of FPGA. So can of this heterogeneous architecture, there are so many choices. But I'm going to provide like a standard to unite all the things. That would be
That's a good question. Hey, ARM guys. The question is ARM going to provide a standard to kind of unify programming model for all of these FPGAs and AI accelerators?
Yes.
Yes.
Already working on?
It is something that we are aware of and working on. As you mentioned, there are various different types of accelerators with different I/O requirements, etc. So being able to standardize, have one single standard to cover them all, may be out of reach, but it is something that we are looking at working on. We're working, you know, from an AI perspective, we're working on the actual software stacks that we would run, whether it be TensorFlow, HighFlow, etc. There's RMNN as well, and so we're targeting RMNN as the AI standard to be able to run AI workloads, regardless of whether you want to use TensorFlow, HighFlow, etc. And whether it's going to be on NPUs, GPUs, or FPGAs. It should have all the hooks in it. It is under development, so I can't give any timelines.
Yeah, but ARM has announced, you know, numerous things around that space that they're doing work. So they'll get there eventually. Like I said, this is a space that's also for us kind of new because we didn't look at that. But if you think about, you know, in an automobile, you don't have time to send an answer back to a server somewhere and get a response. So, so there's definitely kind of an interesting space there.
You had a slide up there that said TensorFlow on it. Is that
that was in package up.
Oh, that was
just a package.
All right.
Yeah. Okay. Other questions? Going once, going twice. Win prizes. Rate the session. The more sessions you rate, the higher your rank is. One more question.
When is there going to be a DSI driver in the standard DSI driver in the pipe for SLES?
I don't know the answer to that. A standard DSI driver. Nope. Stump the chumps.
Okay.
You succeeded in stomping the chumps. All right. That's what I usually wait for to see when it's time to stop. So thank you very much.